Okay, so I hope you understood how we got AO as x plus 1 by 2 and OC as x plus 1 by 2. Okay. Now I want to find what is the length OB. Okay. So AB, this upper line is x, and OA, the radius is x plus 1 by 2. So from this, if I want to find OB, all I have to do is I have to do x minus the length AO, that is x minus x plus 1 by 2. So x minus x plus 1 by 2 is x minus 1 by 2. So this length OB is x minus 1 by 2. Okay. So now I have a right angle triangle OBC whose hypotenuse is x plus 1 by 2 and whose base is x minus 1 by 2. Okay. Now using Pythagoras theorem, OC square is OB square plus BC square. So BC square is OC square minus OB square. So BC square is OC square is what? OC square is x plus 1 by 2 the whole square minus OB square is x minus 1 by 2 the whole square. So x plus 1 by 2 the whole square is denominator will be 2 square 4, numerator will be x plus 1 the whole square, that is x square plus 2x plus 1. So we are using the formula a plus b the whole square using the identity minus x minus 1 the whole square, that is x square minus 2x plus 1, and denominator is 2 square 4. So we have a common denominator here. So when I subtract, the x square and x square term will cancel out. 1 and 1 will become 1 and this 1 will go away. This 2x, when the minus sign goes inside, this becomes plus 2x. So I'll have 2x plus 2x, 4x, and the common denominator is 4. So 4x by 4 is x. So in other words, BC square is x, or root BC is, or BC is root x. Okay, so I found out that BC square is x, or BC is root x. So now what I do is I take my compass, okay, and I take this BC as a radius and I make another circle. Okay, and I make another circle. So since BC is the radius, this the BC, this BC and this length will be the same. So if this is root x, this is also root x. So how do I mark it on the number line? What I do is I draw a number line. Okay, I draw a number line which is going through the diameter of the circles, and what I do is I change the B to the 0 mark. Okay, I change the B to the 0 mark, and where the circle meets the number line, okay, this part is root x, because we saw that this length is root x and this length is also root x. So that is starting from B. Okay, now here what I have done is I have made B as the origin, I have made B as the 0 mark. Okay, so from 0, if this length is root x, this point is root x. Just like, suppose if this number is 9, that is if x is 3 or x is 9, then the root 9 is 3. So this length is 3 and this point is marked on the number line as 3. Okay, I hope I didn't confuse you on that. See, the only thing is we just have to make the number line change that b into a 0, and the point where the second circle, see, not the first bigger circle, the second circle that we made, the second circle meets the number line is root x. So in this manner we can represent any root x. So for any positive number x greater than 0, we can represent root x on the number line. So far we have seen only the square root, okay, of numbers. So now we would like to extend that idea to cube roots, fourth roots, or in general the nth roots, where n is any positive integer. So for this, let us recall your understanding of square roots and cube roots from earlier classes. See, what is a root 8? A cube root of 8. So we know that it is some positive number whose cube is 8. So cube means 3 times multiplying the same number. And we know that it is 2. Okay. So what is the fifth root of 243? It is some number b, some positive number b, such that when you multiply that b 5 times, or b to the power 5 is 243, and the answer to that is 3, because 3 times 3 times 3 times 3 times 3, or you multiply 3 5 times, you'll get the answer as 243. Therefore fifth root of 243 is 3. So from these examples, can you try to define what is nth root of a for a real number a and some positive number n? Can you try to write something on your own? You can pause the video here and wait for the next slide. So first I would like you to try writing something on your own and check if it is correct. So for any number, any positive number a, any positive real number a, and a number n, and a positive integer n, the nth root of a is b if b power n is a. That is, nth root of n is b if b times b times b times, and you do that, b multiply b n times, you get the answer as a. That is, b power n is a. If b power n is a, then nth root of a is b, okay, and b is greater than 0. So we use this symbol throughout this chapter. And this chapter and this sign is called the radical sign. Okay, this sign is called the radical sign. Okay, now let us look at some useful identities. So for positive numbers a and b, we have seen in the beginning that root of a into b is same as root a into root b. Also, root a divided by root b is the same as root of a divided by b. So root of root a into root b is the same as root ab. Root a divided by root b is the same as root of a by b. Now in lower classes we have learned the identity a plus b into a minus b is a square minus b square. How does this come? We take first a and we multiply the second bracket, then we use, that is, we are using distributive law, plus you take the second b and you multiply the second bracket. So a into a is a square, a into minus b is negative ab. Now here we have a ba and you have a minus b square. So ba is equal to ab. So negative ab and ba will cancel out. That will become 0. So we have a square minus b square. So a plus b into a minus b is a square minus b square. So what about root a plus root b into root a minus root b? So if it was a, we use a square. Now we have root a. So we have root a square minus Instead of b we have root b, so we have root b square. So root a square is a, root b square is b. So root of a plus root a plus root b into root a minus root b is a minus b. So a plus b into a minus b is a square minus b square. So if we have a plus root b into a minus root b, instead of b we are having root b. So a square will be a square, root b square will be b. Okay, so we are simply using the identities. Instead of a, here a is the same, instead of b we are using root b. So instead of b square it will be root b square, and root b square is b. So a plus root b into a minus root b is a square minus b. Next we have root a plus root b into root c plus root d. So we take root a, multiply the second bracket, plus we are using distributive property. You take root b and you multiply into the second bracket. So root a into root c will be root of a into c, that is root ac, plus root a into root d will be root of a into d, which is root ad. Now second bracket, root b into root c will be root of b into c, that is root bc, plus root b into root d will be root of b into d, which is root bd. Okay. Next identity is root a plus root b the whole square. So we know a plus b the whole square is a square plus 2ab plus b square. So instead of that we have root a and root b. So instead of a square we have root a the whole square, which is a. Now 2 into a into b, instead of that we have 2 into root a into root b. So that will be 2 root ab. So instead of b square we have, instead of b we have root b. So instead of b square we'll be having root b the whole square, which is b. So root a plus root b the whole square is a plus 2 root ab plus b square. Okay, now let us try to simplify the following expressions. So the first problem is 5 plus root 7 into 2 plus root 5. So what do we do? First we multiply 5 into second bracket. So 5 into 2 is 10. Then 5 into root 5 is 5 root 5. Now we take root 7 and we multiply it with the second bracket. Root 7 into 2 will be 2 root 7. Root 7 into root 5 will be root of 7 into 5, that is root 35. Second example, second question, 5 plus root 5 into 5 minus root 5. So here we can use the identity a plus root b into a minus root b is a square minus b. So here we can use the identity. So we are using 5 square minus, so a square minus b square. So here a is 5, so 5 square 25. B is root 5, so b square is root 5 square, that is 5. So 25 minus 5 is 20. Next example is root 3 plus root 7 the whole square. Here we are using the identity a plus b the whole square. I think you can solve that. And here also we are using the identity a square minus b square. So I would like you to try these two on your own, and this is actually quite simple. We just have to substitute the values of a and b. So here we have a is root 11, b is root 7. So here it is a minus b into a plus b. So because a plus b into a minus b and a minus b into a plus b, both of them gives us the same answer, a square minus b square. Okay.